And in this session, let us complete the other database related stuff. And again, we are not the database administrators and we don't deal with the SQL queries and all. We only manage the database instance, whether it is going to be a MySQL or Oracle, whatever. Our job is to create the database instance, configuring the automated snapshots, creating manual snapshots as per the requirement, and then we need to restore it whenever there is a request to restore the database due to some accidental data deletion and all. We will never ever deal with the data management. For that, the database administrators are responsible to create the tables or executing some SQL queries to fetch the data and all the things. Okay, so in this session, first let's talk about DynamoDB. This is also a database, but it is completely different from the databases what we have seen till now. So whatever the RDS, right? What is the full form of RDS? Relational Database Services. In that relational database services, Amazon is only offering you the SQL databases, or we can say relational databases. So MySQL, PostgreSQL, Microsoft SQL, Oracle, these all are relational databases. Apart from this, we have a NoSQL database. This DynamoDB is the NoSQL database service available on AWS. This is the only NoSQL database available. They don't offer like multiple uh, NoSQL database engines. Like there are multiple, like Cassandra. These all are the examples of NoSQL databases. DynamoDB is a fully managed NoSQL database service provided by AWS. Means no need, same as RDS. We don't install it, we don't configure, we don't manage the database engine which is running in the backend. So I can say DynamoDB DynamoDB is a fully managed NoSQL database service. And this is provided by AWS. In the RDS, we have seen a SQL databases, and it is a NoSQL database. What is a NoSQL database? Generally, it doesn't have multiple tables and all the things. The main use case of the NoSQL database is to store the data in key value format. Key value format. Like if I ask you, like, what is your name? Let us say if you're saying like name like this. This is what the key value. This is the key and this is the value of the key. Whenever you want to store the key value pairs, we have to use NoSQL databases, and the DynamoDB is the best example to store key value pairs. And it gives you, the DynamoDB is offering you single digit millisecond performance. Single digit millisecond means up to 9 is a single digit, right? 10 is a double digit. So if you are fetching the data, if you are retrieving the data from the NoSQL databases, especially from the DynamoDB, you can get a response within 9 milliseconds. So I can say it gives you single digit millisecond latency, or I can say millisecond performance. And one more main advantage is it is a serverless. It is a kind of a serverless which automatically scales based on usage like a traffic, and it requires zero server management. Even if you see the RDS, right? So whenever you feel the CPU and memory is not enough, you need to manually scale up, like stop it, change the instance type, and then start it so that you will get more resources. But DynamoDB, based on the usage, if the more traffic is coming, automatically it will scale because this is serverless. It is a serverless, and it is a NoSQL database, fully managed, extremely fast, auto scaling is available, highly available, high availability, and pay per use. If you ask me what are the features of the DynamoDB, or what exactly Amazon is offering you with this particular DynamoDB, I can say it is NoSQL database, then it is fully managed by AWS, extremely fast because they are offering single digit millisecond latency, auto scaling is available, and it is highly available. What is the last one? Pay per use. How many resources you are going to use, you have to pay for that only. And this NoSQL databases recommended to store key value pairs. Whenever you want to store the data in key value format, then you have to use the NoSQL database. When to use? I mean, like when to use this DynamoDB, especially serverless apps. If you are using serverless applications, or the best use case is like gaming, in the gaming industry, because let us say online gaming, you are playing online car racing with multiple people, right? So what happens, based on your position, you can see like you are in the first position, second position, third position, right? That positions might change every second, right? Means the data to be retrieved from the database in the backend quickly. In such cases, you can use this DynamoDB, NoSQL databases, and for IoT, Internet of Things. Whenever you want to store the data which is sent by IoT devices, example, street lights, smart street lights. What they do every second, they will send the status like whether they are on, off, means that information to be stored, and the same thing to be displayed on the dashboard of the application. Means every second the data to be loaded in the front end application. In such cases also, NoSQL databases will be used. And event driven apps, like if this is happened, immediately something has to be triggered, right? Event driven apps, there should not be any delay, it has to be quick. In such cases, you have to use this DynamoDB. So I can say DynamoDB is suitable for serverless apps, serverless applications. Like on AWS we have a Lambda. If the Lambda wants, if you want to store the data from Lambda to this particular DynamoDB or any NoSQL database, the DynamoDB is the highly recommended. And high traffic APIs, like huge traffic is expecting. In such cases, we can use. And gaming leaderboards. Then what else I mentioned? IoT devices and event-driven apps. These all are the use cases for NoSQL databases. And on Amazon, we have only one NoSQL database, which is a DynamoDB. Okay, now what we do is, let us create a DynamoDB table. DynamoDB table. While creating, we will discuss few other options like auto scaling, right? Serverless. All these things we will observe. Create a DynamoDB table and observe the options available for DynamoDB. And we need some table name, right? I will give this table name as student data is going to be the table name. So here you don't see multiple tables in a database kind of a thing. DynamoDB or any NoSQL database is a kind of Excel sheet. Only you will have rows and columns. That's it. Okay, right. So let us see how to do that. And DynamoDB is a free tier eligible. No need to worry. So in the search, you can type DynamoDB managed NoSQL database. Managed NoSQL database. Click on this DynamoDB. So right now I'm in Northern Virginia region. I'm on the dashboard. Let me click on tables on the left side, and you can see how many tables we have. How many tables we have? No DynamoDB tables. Let us create our first table. Okay, so here let me click on create table. One second. Okay, click on create table. First, what is the first thing? Table name. Can you suggest some table name? Table name. You can use any table name, right? Let me say student data is going to be the table name. Partition key. What is the partition key? It's a kind of primary key, which is going to be the mandatory. Without having this, you can't store any data. You can't create. I mean, like a one column, you can say, a kind of a column. I will say serial number, or let me say name. Name is going to be the partition key. Then sort key. Sort key is a kind of other columns. You can add as many columns as you can. Okay, so here what we do is, let us say table name is going to be the student data, partition key name or student ID, which is going to be the unique, right? Student ID always going to be the unique. Name can be same name, like there might be two different students with the same name. So generally we will use the partition key, which is going to be the unique kind of a thing. You can have sort keys and which are optionals, but again, in the real time, we don't design these tables. Database developers will give you the structure. 99% they will create the table and we will maintain it. Okay, right? Students ID. Table settings. We have two different options: default settings and customized settings. What does that mean by default settings? Like predefined values. Predefined values. These are the predefined values if you choose that. But these predefined values might not be compatible or might not be suitable for your requirement. So what we do, we will choose a customized settings and we will choose each and every option as per our requirement. The first option, table class. Let me write down all those components here. Table class. Can you guess what might be the table class is? There are two different classes. What are those? One is DynamoDB standard and the second one is DynamoDB standard IA. Based on the names, can you guess what might be the reason? So what is the IA stands for? Infrequently accessed. Means based on the type of data what you are going to store, type in the sense the way how the data get accessed regularly. Based on that, you can choose this particular table class. See here, we can select table class to optimize your table's cost, because if the data is not regularly accessed, then I can choose this one to save some money on the storage. If the data is regularly accessible, then we can choose this one. Okay, so let me copy this. We can select the table class to optimize your table's cost based on your workload requirements and data access patterns. We have two things. What are those? DynamoDB standard, which is uh, most commonly used thing. DynamoDB standard. You can see the default general purpose table class recommended for the majority of tables, which stores frequently accessed data. And what is the next one? DynamoDB standard IA, to store infrequently accessed data. DynamoDB standard IA. It is recommended to store the data which is infrequently accessed so that we can reduce the storage cost, right? Okay, let me go with DynamoDB standard because in the real time, especially for production or development cases, we will use this standard only. Okay, right. Then here capacity calculator, just they will show you like how much cost and everything based on your size and all. Each item size might be 1 KB. Item read per second, how many items to be read? Like let's say per second, 10 items will be read, 5 items will be written. Then based on that, I have to choose 5. I mean, they will suggest you how many capacity units you need and how many write capacity units you need and all the things. Okay. So here in the capacity mode, read write capacity settings. What is that read write capacity settings? Means based on this configuration, the database read and write capability will be defined. We need to choose read and write capacity as per the requirement so that read and write operations will be effective. Effective in the sense with high performance without any delay. Let us say, for example, per second, there are 100 read operations. If I say, if I configure the table, which can only supports 10 read units or 10 read queries, anytime 90 queries will be in the queue, right? Means 90 people will get the output with a delay. So we have to choose this capacity as per the requirement. And we have two different capacity modes available. One is on demand and second one is a provision. One is on demand and the second one is a provision. On demand means based on the requirement, automatically the capacity will be increased and the capacity will be reduced. So whatever you need, or I can say that the description is not effective, based on the usage, capacity will be adjusted to provide the best performance with lowest possible charges. That is what on demand. Provision in the sense we need to set how many capacities we need and all. We need to set a minimum capacity. We need to configure maximum capacity. Let us say if I set minimum capacity as a 5 and maximum capacity as a 40. What does that mean? Even there is no load, I have to pay for 5 capacity units. And it will automatically scales up to maximum capacity units. But here we are wasting some money. So here it will, in the provision, we need to choose the read and write capacity for the table and will be charged as per the capacity configuration. How much you have set, for that you have to pay. And also auto scaling is available, or auto scaling can be enabled with provisioned capacity mode. Means by default that what we call that auto scaling is not enabled. But in the on demand in itself, based on your demand, the capacity to be adjusted by default auto scaling. But here provision, you can enable or you can disable. You can enable or you can disable in the provision. On demand, by default, that is going to be auto scalable. And here we can see read and write capacities, right? So here the read and write capacities are decoupled, which doesn't impact others. What does that mean? Let us say I set read capacity 5 and write capacity 5. If there are huge read operations happening, that will not impact the write capacity, the write operations, because the write operation capacity units are separate and read operation capacity units are separate. That is what decoupled. What if tightly coupled? Whenever the read operations are increasing, all the resources on the database will be consumed by the read operations, and there are not enough capacity, the resources to handle the write operations. That is what tightly coupled. Decoupled means loosely coupled, which are not dependent on each other, which will not impact the other. So that if there are heavy read operations, that will not impact the write operations. Okay. So this warmth throughput is like kind of new feature available. What it will does, it will prepare your table for the upcoming heavy usage. Let us say, uh, what do we call that? Let us say in the whenever there is a chances of getting more read operations, it will prepare your table to handle such peak events without disturbing, or it will make ready your table. That is what the warmth through. And then secondary indexes like other columns. I have set student ID, student name, which class he is into, which department, mobile number, email address, contact. Those all are the secondary indexes which you can create. Encryption, encryption at rest, data at rest encryption. You can choose whatever the key you want. Deletion protection, if you want, you can select. Resource based policy, you can set some policies here so that applications can, let us say, if I want to allow Lambda to access, so I need to create a JSON policy so that your application or a Lambda service can communicate with table to read the data or write the data. And click on create table. The table is getting created with just one column. You can see status creating. Just wait for, just it won't take much time. What happened? Active, right? Okay, now you can see all the options. Read capacity mode is on demand, write capacity on demand, total size 0 bytes right now, total byte 0, stable class is standard. If you want to change, you can change a few options also later. Okay, now create some data into the DynamoDB table. Here, the advantage with the NoSQL databases is on the fly, you can create new columns also. But in the SQL, I mean, these are all are database related things, database administration. In the SQL database, if there is no such column, you can't create the data, right? But here, at the time of creation, you can create a new columns also. Let me show you. Student data table, click on that. Explore table items. And you can observe, by default, the point in time recovery is off. We need to enable it. That also I will show you. Explore table items, create item, student ID 1, create item. Yes, student information has been created. Let me create few more. 2. For this, I want to add a new attribute, string, going to be student, let us say the name 2. Let me create few more. 3. Right. Okay, let me show you the values. See, 1, 2, 3. Whenever you want, just you can add it. You can edit. You can select this. Can We'll get edit icon here. Where is this? Edit. Add new pair string. Name 1. Save and close. This is how you can create the data. But what is our job? Our job is our job is to maintain, right? Like manual backups, automated snapshots, and all the things. Let us observe, does the automated snapshots enabled or not, right? Observe the automated snapshots and PIT recovery. Enable it if not enabled yet, because it's the most important thing, right? Okay. So where we have to check, just this is our table, right? Click on the table. Let me close all this. We have different tabs here, right? And here you can see one option called backups. Click on the backups. And this is serverless, right? On demand. Okay, right. Now here, what is the status of point in time recovery? Off, which means By default, point in time recovery is not enabled on your DynamoDB tables. We have to enable it manually. How to enable? So note, by default, PIT recovery is not enabled on DynamoDB table. So first thing, enable PIT recovery and select a retention period, like how long that data to be stored, right? Okay. So this one, right? Click on edit, turn on point in time recovery. You can choose the retention period. That's it. Automatically, they will start creating the automated backups and all the things. Okay. Now, what I do is create three more records into the DynamoDB table. Total is going to be six records. Total six records. Let us verify the recovery process also. Okay. So how to create same thing? Explore table items. Already three, right? Create item. Four. Create. Again, one more create item. Five. Let me add a new attribute. Name. Name five. Create item. Create item. A six. Add. Can I create multiple attributes? Yes, you can. Let me show you that also. And let me add one more attribute number. I can say contact number. Let me add one more string, email, name6@gmail.com. Let me click on create item. See here, right? Okay. So at what time? At 7:02 p.m. we created. So after some time, we will delete some data and all, and we'll verify. Okay. So automated backups will be taken automatically. Every time there is a change, the point in time recovery will create an automated snapshot in the backend. Now, how to create a manual snapshot, because manual snapshots also plays an important role in the real time, because whenever you want to modify something, you in the sense anyone, what they do is first they will create a snapshot and then only they will proceed with the changes. Why? Because of those changes, if something got broken, then immediately they will recover that using the manual snapshots. Create a manual snapshot from the table. When we are creating at 7:03 p.m. Let me show you how to. So go to the DynamoDB tables. This is the table, right? Click on the table. And here, go to the backups. Can you see an option called create backup? Create backup, create on-demand backup, source table, default settings, or you can customize it also. Default setting in a sense, uh, they will use AWS backup, transition to cold storage, no IAM roles, everything will be automatically chosen. Customize settings, backup with the DynamoDB or backup with AWS backup. You can have, I mean, with this AWS backup, we have extra features like you can copy this backup to a different region or a different account and all. So backup name, I can say manual backup, which contains a 6 records, and click on create backup. This is the manual backup and done. Now let us verify the recovery process also. What I do, delete any two records from the DynamoDB table at 7:06 p.m. IST. Then recover the deleted data using PIT recovery by selecting recovery time as 07:05 p.m. IST. We are going to delete the data at 7:06, right? So I will recover the database to 7:06, sorry, 7:05, 1 minute before the actual deletion of the data. Same as with the RDS, the concept will never change. The concept will never change. Just we are applying in a different way. There we applied on the RDS, here we are applying on the DynamoDB. That is the difference. Okay, let's wait until the 7:06. Then I will delete the data. It's 7:06, right? How to delete? Same thing. Just go to the explore table items. Click here. Wait. Where is the table? Yeah, here is the table. What happened? Go back. Tables. This is the table, right? Click on the table. Here, explore items. Choose whatever you want to delete. 531. Actions. Delete items. Delete. 3 items got deleted at 7:06 p.m. Now I want to recover. How to recover? Using point in time or recovery. How to do that? Same procedure. Just go to the table, backups. Right, let me scroll aside. Restore. Restore to a point in time. Name of the restore table, I will say restored students data. A new table will be created. You need to point in time record. You need to specify the date and time. Date is 18th. Time 7, right? 7 in the sense 19:05:00. Hours, minutes, and seconds. Restore the entire table to same region or to a different region. That is also possible. And click on restore. Now you can see a DynamoDB table is getting restored using the point in time recovery, which can recover all the data. Just wait, let me refresh. Still, you can see only one table. Let me go to tables, refresh. Did I click on restore? Restore. What is the name I said? Restored underscore student data. Specify date and time. Today is 18th, right? Yeah, Tuesday 18th. 19 05:00. Restore the entire table, Northern Virginia. Yeah, restore. Why? What happened? No error. Okay, let me refresh the page. Sometimes the UI is not that much good. Yeah, that's the problem. In the UI, it was not reflected. Just I did a refresh. Now I can see two different things. But that's okay. I use a different name. That's why no error. If I use the same name, definitely I might get an error that already a table with the same name exists. That's okay. It will take few minutes of time, not like 5-10 minutes, just a few minutes. Once it is ready, we can check the data is available. Okay, right. So any questions on the DynamoDB? Is a simple for us being a solutions architect. It is simple, and backups and everything you can see here. If you want to delete the backup, you can select this backup, delete. That's it. Later I can delete all these things. Are you guys clear, or any questions with creating the DynamoDB and managing the DynamoDB table for automated backups and manual backups? If you guys are clear, I will go with some topic. There's a theory part. We can't do the practical here for this elastic cache because it requires a developer things and all. Actually, developers will use this, they will configure this feature on their applications. Elastic cache. If you guys are clear with the DynamoDB, just will go with elastic cache. I will explain with simple diagram and all. so that you can understand what exactly that is. Okay. So coming to the Elastic Cache is a fully managed in-memory cache service. In-memory cache service for the database. Like your browser is having a cache, right? Browser's cache. What is the use of the browser's cache? Whatever the web pages you visit, those web pages will be a temporarily cached, like temporarily stored in your browser until you close the browser, close and reopen the browser or something. What is the advantage? If the particular data is get cached in your browser, and if your browser is still trying to access such data, instead of retrieving the data from the actual server, from the browser's cache, the browser will serve the such content, right? So that latency will be reduced, performance will be improved. The same way, the Elastic Cache is an in-memory cache to improve the application speed by caching the frequently accessed data. I will give you a simple example so that you can understand. If I go to Amazon.in online store, right? What exactly will happen? You can see some images and all, right? Like this. These many images got loaded. These many images got loaded, right? Means if 100 or 1,000 people access the home page of the Amazon.in online store, those many images will be loaded for everyone, right? Means for every time the application sends a request to the database, it will retrieve such data from the database. Means unnecessarily there is a load on the database. That's the first thing. Unnecessary load on the database. And the second thing, the database is somewhere across the globe. It has to load the data. So there might be some delay. To avoid such things, Elastic Cache will be used. Let us say this is your database, right? And somewhere here you use Elastic Cache like this. And somewhere here you are going to have your application. Okay. Now how it works? Whenever there is a user try to access something, right? So application will send a request to the Elastic Cache. If there is no if there is no such data available, it will go there and it will stores that data. And now whenever a second user is trying to load the same image or information, from here, the particular data will be served. So no need to retrieve the data every time from the database in the backend. Elastic Cache will cache the frequently accessed data, not the entire data. Let's say database is having like 10 GB data. That doesn't mean Elastic Cache will cache all the 10 GB of data. It is in memory, right? In memory. Let us say in your machine, you have two types of storages, RAM and hard disk. Which is faster? Obviously, RAM is faster, right? Why? That's why whenever you are doing copy from like what we call that, whenever you're doing some copy process, the speed depends on the hard disk. RAM, temporary storage, but it is a faster. It is a faster, right? Yes, Elastic Cache doesn't have any storage. It will have a memory, temporary storage, which can serve the data faster. That is what the Elastic Cache is. Elastic Cache is to improve the performance of your applications by caching frequently accessed data. So I can say it is a fully managed in-memory cache service used to improve the application speed by how? By caching the frequently accessed data so that the data will be served from the elastic cache instead of loading from the database every time. And we can reduce the load on the production database. There is something called indexing, right? They do something called indexing and they can cache all the data. It's in memory, right? So automatically the performance will be very high. And Elastic Cache supports a two in-memory database engines. We can call this as an in-memory database also, but technical word is in-memory cache service. And I can say it supports two engines. Like RDS supports seven engines, right? It supports two engines. What are those? Redis, which is most popular, and the second one is Memcached. Why to use Elastic Cache? Why to use Elastic Cache? Already we discussed it, right? It is like going to be super fast, reduces load on databases. What databases? RDS or DynamoDB or for both? Yeah, it supports for both. Any type of database. It can be RDS or it can be a DynamoDB. And it automatically scales, auto scaling supports. It also supports, already I said, highly available, right? So multi-AZ with failover is available, and that is only for Redis, not for Memcached. And it is already said it is fully managed by AWS. So if you are planning for a certification exam, you must know about these two, like Redis and Memcached. These are in-memory because they will ask you a question, a kind of a scenario-based question. So application is all the time loading the data from the database, and latency is very high, and the users are experiencing a delay in loading the web page with all the content. And thousands of people are accessing the homepage every minute, and that is impacting the right efficiency of the database. So what type of service you will use or you prefer to improve the application performance? Blindly, you have to use Elastic Cache. Whenever you see to improve the performance of the read queries of a database, Elastic Cache is the first priority. Elastic Cache is the first priority. Always the Elastic Cache is available in front of the database. All the requests go to the Elastic Cache. If the data exists here, it will deliver. If not, it will go to the RDS, captures, cache, and then it will deliver. From then onwards, every user will be delivered such content from the Elastic Cache. Right? Any questions on the Elastic Cache? No? Okay. So this is the table, right? We recovered earlier before starting the Elastic Cache. Just I would like to check the content, whether all the data got retrieved or not. See here, all the data got retrieved. Right? And how to delete the table? Simple, like how we delete the regular databases the same way. Select the table, actions. Okay, here it is, directly delete. I want to delete all alarms and everything. I don't want to create any on-demand backup. You might have a question like, why there is an alarm, CloudWatch alarm? We haven't created, right? The reason is we configured auto scaling, right? Auto scaling is available whenever the existing resources are utilized by 80%, then the capacity will be automatically increased. How it will monitor? It has to be monitored, right? That's with the help of CloudWatch service. Going forward, we will see that CloudWatch service also. Let me delete all. I'm just cleaning up the DynamoDB tables. And I will delete that manual snapshot also, which we have created earlier. And if I go to backups, I can see manual backup, right? Delete, type delete. Okay, there is a system backup, automated backup, which was created during the database creation, and that will be automatically deleted. No worries. Okay, right. And we have one more type of a database. We have one more type of a database. Already we have seen SQL and NoSQL. I'm not talking about those things. I can say categories. Do you guys know there are two categories of databases available? Have you ever heard? OLTP, OLAP. Have you ever heard about these terms? OLTP and OLAP? No? Let me write down the full form. Online transactional processing. OLAP stands for online analytical processing. Whatever the databases we covered so far, those are online transactional purposes. Online transactional processing databases means where the data will be read, where the data can be written and all. Whereas OLAP, online analytical processing, those are designed especially for analytical purposes. Those are especially for analytics, data analysis means those databases are designed to provide you high read operations. In general, whenever we do something called data analytics, we don't modify the data, right? Whatever the data exists, we read the data and we'll perform the analysis. That is what OLAP. So on Amazon, we have a database called Redshift. Again, this Redshift is not for solutions architects or developers or DevOps guys. That is for big data. Whoever is going for big data certifications or going for data analytics, working on data analysis, right? For them, this Redshift, I mean, they use this Redshift. All the data will be loaded into the Redshift because it is designed to provide you high read query capabilities. Like they support something called parallel uh, processing, parallel query execution, or massively parallel processing kind of a thing where it can execute multiple queries at a time. No need to wait to stop a read query to execute another read query and all. It can execute parallel queries at a time. That is what the Redshift is. Redshift is OLAP type of a database, which is available on Amazon. The main purpose of the Redshift is for data analysis. I can say Amazon Redshift is a fully managed petabyte scale data warehouse service from AWS. So why we are covering this? Because already we covered all database types. So why should we leave this Redshift? That's why I'm going to cover. But sometimes you might expect a question from this Redshift in the certification exam, even though you are going for solutions architect. Just they will use a term called OLAP in the entire question, and blindly you have to go for the Redshift. If you understand the concept, like the use case of the Redshift, that will be easy for you. That okay, for this kind of situation, we have to go with Redshift. Okay, and it is designed. I can say analytics, data analytics, or big data processing, or running data sets, sorry, running SQL queries on huge data sets. Like I have like 1 million data, 1 million records, and I want to run a SQL query to fetch the data from 1 million or 1 billion records. If you execute on the normal MySQL database, it takes hours of time, but it will give you in minutes. And this is also for BI and reporting. There's something called Power BI and all, right? Business intelligence tools. And again, the most important thing, the Redshift is not a transactional database. like RTS. Means you can't use this as a regular database for your applications. This is purely for analytical purpose. I can say it is for OLAP, online analytical processing. What does that mean? It is for large read heavy applications, not for write and all. Why Redshift? It supports or it uses massive parallel processing, which improves the performance, and it is highly scalable. Like today, you have used it with 1 terabyte, and next day, if you are going to upload 10 terabytes of data into the database, it is a you can increase the capacity. It integrates with S3, like you can fetch the data from S3 to what we call the Redshift, or once the reports has been generated, that can be stored into S3. There are some data warehouse tools called Glue, Athena, and Kinesis. These are like data analytical tools. This will integrate with that, so that instead of using the third-party tools, directly you can use these tools to build data lakes, data warehousing, and all the things. So tools like or I can say to build data lakes and data warehouse. Easy, no need to depend on the third-party tools. Obviously, it is the cost-effective and SQL compatible. It is SQL compatible. So, I mean, if you ask me the core concept, which is not required for us, in this Redshift, there is going to be one a leader node and one compute node. I mean, if you have some idea about Jenkins, right, or Docker Swarm kind of a thing, there is one leader node, even in the Kubernetes leader node and worker nodes. The job of the leader node is to share the job with the worker nodes, right? Worker nodes will do the actual work. And here also in the Redshift, there is a leader node and compute nodes. Leader node is going to assign the task to the compute nodes. Compute nodes will perform the jobs, and the result will be collected by the leader node. It will consolidate and it will share, or it will generate the output. Okay, so when to use this Redshift? Whenever you have billions of rows of data, and if you want to build some dashboards using Tableau, Power BI, QuickSight, such kind of tools, or whenever you want to process the logs, huge logs, or whenever you want to run some ETL tools like Glue and all, you have to use this one. Or in a simple way, you can say OLAP purpose, and it is not recommended for OLTP. If you do so, if someone creates some data, it takes huge time to store that data, because it is not designed for write queries and all. I mean, I'm not saying it doesn't support, it supports, but instead of taking 1 second to write the data, it might take 10 seconds or 20 seconds of time, 20 times slower than OLTP, right? That's why it is purely for OLAP. It is purely for OLAP, analytical purpose, or you can say data warehousing tool. You can say whenever you see something called data warehousing or a data analytics or a data lakes, data processing, generating the reports, in all these cases, the only option to store such huge data is Redshift. Okay, all right. So any questions on this? They are small topics only, not mandatory or not required. Just for to get some idea and overview about all these, just we covered these three things. Any questions? Any questions on these topics? Okay, so if you guys are clear, we already completed the database. We have very few topics left. Let me list out the topics once. Elastic Beanstalk, a kind of platform as a service, one day. CloudFormation one day, CloudWatch one day, then Lambda one day. Almost like in the next 6 to 7 classes, we can complete all these. Okay. So mostly tomorrow, I can upload the remaining videos also to the YouTube. I think I haven't uploaded right in the recent one from the last 1 week or so. I will upload those videos also, but I am updating the class notes day by day. Just try to complete the practice. If you have any questions, just let me know. Okay, right. Yeah. Any other questions?